So in this class, I will explain another problem on concurrent force system, which is review examination problem R 2022. In this case, he has given two forces, 500 Newton force making an angle 30 degree with x-axis, 1000 Newton force making an angle 30 degrees with y-axis, and he has given the resultant force R 1000 Newton making an angle 45 degrees with x-axis. The question is, there is another force which is not given here, unknown force F. There is an unknown force F. We don't know in which quadrant it lies. So we have to find out that unknown force F and its direction so that the resultant acts like this. So that means here there are three forces. Resultant force he has given, but constituent forces are three. One is 500 Newton, another is 1000 Newton, one more force F is there which is unknown, that we have to find out. When such a problem is given, what we have to do is, we have to assume that the unknown force lies in the first quadrant. So let us assume that let unknown force F acts in first quadrant. So if it is like in the first quadrant, so what happens? We have to take like this F. Let me take the angle made by that F with respect to x-axis as theta, so that the components of this F both are positive. So this is F cos theta, this is F sin theta. So this is the third force. So first force is 500 Newton, second force is 1000 Newton, third force which we have to find out is, we assume that it is F, it lies in the first quadrant. So we have to write the components. Now, as usual, we will write the algebraic sum of all the forces in x direction. So treating forces acting towards right positive. Now we have to resolve these forces. So let me take this 500 Newton force. This 500 Newton force is acting at 30 degrees with x-axis. So its components become now. So both are positive here. So 500 cos 30 is this horizontal component and 500 sin 30 is the vertical component. Then if I take this 1000 Newton force, 1000 Newton force is acting like this, which is making an angle 30 degrees with vertical. Making it vertical. Therefore, in this case, the components will be, so if you take this as 30, this will be 60. So you can write this as 1000 cos 60, which is the same as 1000 sin 30, and this is 1000 sin 60, which is the same as 1000 cos 30. So in any way, in any form we can write. And we know that the components of this unknown force F are F cos theta and F sin theta. Now these three we have to combine now to get this sigma fx and sigma fy. So if I write sigma fx, so the first force sigma fx, it is x component acting towards right, therefore it is positive, 500 cos 30 positive. Second force also it is positive because it is acting towards right, plus 1000 cos 60. For the third force also it is positive because we have assumed in the first quadrant, so it becomes plus f cos theta. So this is the sigma fx term. If you simplify this you will get 500 into, so let us simplify this, 500 into cos 30 plus 1000 into cos 60. So it becomes 933 plus f cos theta. So this is the expression for sigma fx. I will call it as equation 1. Next, I will take sigma fy. Here, force is acting upwards positive if I take downwards negative. So component of this will be 500 sin 30 upward. So it is positive 500 sin 30. Whereas component of this is also upwards plus 1000 sin 60. And component of this also is upwards, therefore that is also positive, plus 5f sin theta. Now if you simplify this, you will get 500 into sin 30 is 250 because sin 30 is half. So 250 plus 1000 sin 60. 1000 into sin 60. So if you add both of them, you will get 1116 plus f sin theta. So this is equation 2. Now we have got expressions for sigma fx and sigma fy. Now in this case, the resultant he has given at an angle with respect to x-axis. Now what we should, the concept is here, since the resultant is given like this, resultant is also 1000 Newton, R value is also 1000 Newton, but it is making an angle 45 degrees. If you resolve this resultant force into two components, x component of this resultant will be like this, y component of this resultant will be like this. So this is 1000 cos 45 and this is 1000 sin 45. Sin 45. So 1000 cos 45 is it is 707.1. Okay, I will take 707.1. This is also 707.1 Newton. Now, according to the concept of resultant, a resultant force can be shown like this. If you resolve the resultant force, the components of resultant force it will be sigma fx and sigma fy. Please note this. The components, rectangular components of the resultant or orthogonal components of the resultant are sigma fx and sigma fy. Now if you compare this with this, so your sigma fx value will be 707.1 and sigma fy value also will be same. So this is how we have to do it. Now substituting for sigma fx and sigma fy from these two, 1 and 2. So substituting from equations 1 and 2. So sigma fx we have got 933 plus f cos theta, that will be equal to 707.1. The other equation is this, sigma fy is equal to, sigma fy is 1116. F sin theta will be equal to same thing, 707.1. Now what we have to do is we have to solve these two equations to get the unknowns f and theta. So theta is the angle made by f and f is the magnitude. So here suppose if I take this as equation 3 and equation 4. From solving 3 and 4 you will get f and theta. So now the question is how to solve. Solving 3 and 4 we get f and theta. So f is the magnitude of the force, unknown force, theta is the direction of the unknown force. Now to solve that, what we will do is from 3 what happens, f cos theta will be 707.1 minus 933, which comes out to be minus 225.9. Similarly, from the fourth equation, f sin theta is equal to 707.1 minus 1116. It comes out to be minus 408.9. Now once you get a system of equations like this, f cos theta and f sin theta, by dividing this f sin theta by f cos theta, you can get tan theta. So that is how we have to solve. So f sin theta divided by f cos theta will be equal to minus 408.9 divided by minus 225.9. So here f can be cancelled out. So what you will get is tan theta. Sin theta by cos theta is tan theta. The minus becomes positive. So you will be getting tan theta as 1.81. So therefore theta is tan inverse of 1.81. Let us see what is the degree. So tan inverse of that will be 61 degree. So 61 degree, 61.1 degrees. So this is what we get. This is the value of theta, the angle theta, which that unknown force f makes. Now to find f, you can use one of the equations. So we have f cos theta is equal to 225.9. Since magnitude f is always positive, I will consider the positive value instead of taking minus value. So I will consider the magnitude as positive. Therefore, positive value I will take. So therefore, f is equal to 225.9 divided by cos theta, which is cos 61.1 degree. So now the value of this will be 225.9 divided by cos 61.1 will be equal to 467.4 Newton. So this is the magnitude. So this is the direction of unknown force, and this is the magnitude of unknown force. But in which quadrant it lies, that is also important. Initially we have assumed that force F lies in the first quadrant, but after seeing the simplifications, you can see here how to decide the quadrant in which that unknown force F lies. So we have to use this concept. So here, if you take the two-dimensional coordinate system x and y, in the first quadrant if it lies, f cos theta and f sin theta both will be positive. In the second quadrant, if the force f lies, then f cos theta will be negative, x component will be negative, y component will be positive. That means f cos theta is negative and f sin theta will be positive. In the third quadrant, if it lies, both are negative, x component, y component both are negative. So f cos theta negative, f sin theta is also negative. In the fourth quadrant, if it comes, our x component will be positive, whereas y component will be negative. So this is how we have to decide in which quadrant that unknown force F lies. Now in this problem, if you observe, f cos theta is negative, f sin theta is also negative. Therefore, the unknown force F lies in the third quadrant. So we can show the unknown force like this. This is the unknown force F, whose magnitude is 467.4 Newton, and direction measured from the x-axis, it is 61.1 degree. So this is how we have to show the unknown force finally. So initially we will not be knowing in which quadrant that force F lies. Resultant is given, one unknown force will be there. That unknown force magnitude and direction we have to find out. After getting the values, you have to decide in which quadrant that F lies based on this criteria. So anyway, in any problem of this concurrent force system where the unknown force is asked, so you will be having two unknowns because we have two equations to be used, one with respect to sigma fx, another with respect to sigma fy. We will be getting two equations. If the resultant is acting at some angle, then this is how we have to do the problem. If the resultant is acting along x direction or y direction, then last problem which I did, so in the last video which I did, which I have done, like that we have to use the equations wherein either sigma fx will be 0 or sigma fy will be 0. So whereas here, since r is making some angle with respect to x-axis, we have to consider sigma fx as the x component of r and sigma fy as the y component of r, and that we have to equate to the respective expressions here, and we have to solve the equations.